Welcome back guys to our very last class that we will cover theories. So from the next classes we will start on the practical parts, looking at packet tracer, how we can use packet tracer, moving forward to switching and routing. So this is class 7 and we will cover network domains. Under network domain we will understand what a broadcast domain and collision domain means, and we'll move down to data casting or data transfer methods, then the URL. Then we will summarize our class by explaining what a port number means. Okay, so let's see what we have next. Network domain. A network domain means an area, a place or a location in a network. A domain simply means an area. Okay, so a network domain means an area, place or a location in a network. I hope you understand that. So let's start by broadcast domain. A broadcast domain is an area in a LAN environment. It is an area within a local area network environment. Each LAN is a separate broadcast domain. Understand this. Each LAN is a separate broadcast domain. Okay? When one message is sent to a device, it goes to all other devices connected in the network. So let's see in this case, in the below diagram. Let's say this one is device A, B, C, D. So A wants to send a message to device D, but that message goes to all the devices. A broadcast domain means one device sends a message to all other devices in the network. Okay, so it is the domain in which the broadcast is forwarded. Domain is an area. It is in the area in a network in which the broadcast is forwarded. A broadcast domain contains all devices that can reach each other at the data link layer by a broadcast. So I hope you understand what a broadcast domain means. A broadcast domain is a situation whereby one device sends message to all other connected devices in the network. Alright? So let's understand what a collision domain means. A collision domain refers to a part of a network where packet collisions occurs. Do you understand this? Collision. It's like an accident. Collision. Two things collide. Okay? So collision domain occurs when two or more devices sends a packet at the same time on the shared network segment. The packet collide and both devices are required to resend it again. That really wastes bandwidth and reduces network efficiencies. Collision domain, two or more devices sends data at the same time and the packets collide and the devices are required to resend the data again. Let's say A is sending data at the same time C is sending data. The data will meet at this device and collide, leading to data loss, and the devices will be required to resend it again. Okay? Understand what a broadcast domain and collision domain means. Alright, let's see what we have next. Broadcast domain of hub, switch, bridge and a router. The devices in a network have different broadcast domains. So we are going to look at the broadcast domain of hub, switch, bridge and a router. So let's start with switch, bridge and hub. They have the same broadcast domain. That's why we have grouped them under one category. Okay, they have one broadcast domain even if many ports are connected. Here the broadcast domain do not depend on the number of ports connected. Each port is in the same broadcast domain. Then this is now the big point here. Under switch, bridge and hub, each port is in the same broadcast domain. Okay, for example, a switch or a hub or a bridge connecting 8 PCs has only one broadcast domain because each port is in the same broadcast domain. Let's see here down. Let's see down here. This switch is connecting how many devices? 1, 2, 3. This hub is connecting how many devices? 1, 2. Okay, so the broadcast domain in a switch does not depend on the number of ports connected. The broadcast domain in a switch is always 1, despite how many ports are connected, because each port is in the same broadcast domain. All the ports, all the connected devices in the ports, all the connected ports have the same broadcast domain in both switch, hub and the bridge. We have not included the bridge diagram here, but you just understand that. Okay, so let us understand the broadcast domain of a router. The broadcast domain of a router is equal to the number of connected ports. The number of broadcast domain in a router is equal to the number of connected ports. Like this router is connected to which, how many devices? 2. So the broadcast domain in this router is the number of broadcast domain in this router is 2. Broadcast domain. Suppose that it was connected to another device here, another one here. We can say this one is 3, 4. We can say it's 4 BD. Broadcast domain. Number of broadcast domain in a router is equal to the number of connected ports. Okay. Now the broadcast domain in a router depends on the router ports connected. Each port in a router is a separate broadcast domain. See, but in hub, bridge, switch, each port was in the same broadcast domain. A router connecting 8 PCs have 8 broadcast domain. It depends on the number of ports connected. The number of ports connected is equal to the number of broadcast domains. I hope you understand the broadcast domain of various devices. Kindly understand that. It's very simple. For hub, switch, bridge, it's 1. But for a router, it depends on the number of connected ports. Okay? Alright, let's see what we have next. A collision domain of hub, switch, bridge and router. So in the case of a hub, we only have one collision domain depending on the number of ports connected. Even if there are many devices, let's say 20 devices are connected to a hub, the number of collision domain in that hub is only 1. Okay, here the collision domain do not depend on the number of ports connected. That's what I've just said. Even if you have 20 devices, the collision domain in a hub will be 1. Okay, alright. Each port is in the same collision domain, even if there are 20, but they are in just the same collision domain. Alright. A hub connecting 8 PCs has only one collision domain because each port is in the same collision domain. In the same collision domain. So hub has only one collision domain. Okay. Then number 2, switch, bridge and router. The broadcast domain in a router is equal to the number of connected ports. The broadcast domain in a router, switch, and a bridge is equal to the number of connected ports. Now it depends on the number of ports connected, the number of switch ports, router ports, or bridge ports connected. I forgot to include bridge switches here. You can understand that and include later. It depends on the number of a router, switch, bridge ports connected. Each port is a separate collision domain. For example, a router or a switch or a bridge connecting 8 PCs has 8 collision domains. Okay, this switch is connecting, let's say this one is 1, 2, 3. The number of collision domains here will be 3. Okay, because each port is a separate collision domain. But this router is connecting how many devices? 2. 1, 2. Now the number of collision domains in the router is 2. 2 collision domain. I hope you have understood this broadcast domain and the collision domains of various devices, the various networking devices such as a hub, switch, bridge, and a router. So in that case, let's see what we have next. Data casting method or data transfer methods. Under data casting methods, we have what we call Unicast, Multicast, and Broadcast. So a Unicast address represents a single LAN interface. A unicast frame is sent to a specific devices, not a group of devices in the LAN. Let's say this one is device 1, 2, 3, 4. A unicast address represents a frame that is sent to a specific device. Suppose device 1 wants to communicate to device 4. The frame is sent directly through the switch to device 4. That's what we call a unicast address. A multicast. A multicast represents a group of devices in a LAN. A frame is sent to a group of devices. Suppose this device 1 wants to communicate to device 3 and 4. That's a group, not all, but a group of devices. Let's say there was another device connected here, device 5. So device 1 wants to communicate to group 3, 4, and 5. So a multicast address represents a frame that will be sent to these 3 devices. That's a group. It will be sent to all the 3 devices because it was a multicast address, and device 1 wanted to communicate to only 3 devices, a group of 3 devices, which are device 3, 4, 5. Okay, so a broadcast address represents all the devices on the LAN. Frame sent to a broadcast address will be delivered to all devices in the LAN. Suppose device 1 sends a frame. That frame becomes a broadcast when it's delivered to when it's sent to all the devices in the LAN except the sender. So a broadcast frame will be sent to all these devices in the LAN except the sender. Unicast, a frame is sent to a specific device, one-to-one, specific. But multicast, a frame is sent to a group of devices. A group of devices, not all, but a group, a selected few, okay, or can be many, but just remember this, a group of devices. Now a broadcast means a frame is sent to all other devices connected within that LAN except the sender. The sender sends the data, the frame. That's why it doesn't receive it. Okay, alright, let's see what we have next. What is URL? Uniform Resource Locator. This is a string of characters that contains information about how to fetch a resource from its location. So it specifies the primary access mechanism and the network location of the resource. Like what I've just said, the case of Google. Well, a URL string consists of three parts. A protocol that is used to connect the servers. A protocol can be HTTPS, that's mostly commonly used one, and it's secure. That's why it's called HTTPS. HTTP is not secure because it doesn't have this S I mean. So HTTP with S means it's secured. Okay. So the second part of the URL is the server host name. Okay. Then the third part is the document part. Like in this table, the protocol is this one, the host name is this one, and the path is this one. Okay. For example, so this is what will help us understand it much better. Okay. So we have a URL here, this one. We have a URL here. So this part represents the protocol. This FTP : // this represent the protocol. This is a URL character or string. So the first part represent the protocol, FTP, file transfer protocol. We use it to upload or download files. Okay. Then the host name. The host name is www. Even if it was google.google.com. Then which file do you want to upload or download? It's called uploads.zip. So the upload.zip is our path, but www.google.com was the host name. It's very simple. I hope you understand this one. I hope you understand this. I hope you understand this one kindly. Okay, let's see what we have next. What is port number? Port number is very important in networking because every device, every application in the internet must have a specific or a unique port number. For example, UDP and TCP and UDP protocols. Under TCP, we have protocols such as FTP, which uses port number 20 or 21. We have SSH, which uses port number 22. We have Telnet, which uses port number 23, and so on and so forth. Under UDP, we have DNS, which uses port number 53. SNMP, which uses port number 161, and so on and so forth. So a port number is a 16-bit number used to identify specific application or services in the network or in the internet. You can say that. So when we say a port number 20, we know that's which protocol? FTP. It uniquely identifies applications or services in the internet. When we say it's port 23, we mean that which protocol is that? It's Telnet. The logic of port number. Very simple. So TCP and UDP specify their source and destination port number. When you want to send a data or you want to communicate, the UDP and TCP protocols will specify what is the source port number and what's the destination port number attached to the data. Okay, so in their packet headers that information along with the source and destination IP addresses. The data is attached with IP address, source and destination IP addresses, source and destination port numbers. Okay, all right. So then The TCP or UDP protocol, these are transport layer protocols, will enable these applications running on the host devices to communicate. For example, let's get here. This is a computer. This is a server. This computer wants to communicate with this server. Earlier, client server communication. When sending a request in form of a data or packet, that packet is attached with a source and destination IP address and source and destination port. Then the server will receive that packet. It will translate that, oh, this packet was meant for me and is from which device? This device with this IP address and source port number. Then when the server is sending back the response data or packet is attached with a source IP address which is of the server and the destination IP address which was which is of the computer. Then the source port number which is of the server and the destination port number which is of the computer. Alright, so what's very important under port number is a 16-bit number that is used to identify application or services in the internet. Every protocol or every service in the internet or network has a specific port number. Two protocols cannot have the same port number. Never. HTTP is known for port number 80 and so on and so forth. So I hope you have understood what port numbers means. Okay, let's see what we have next. Okay, that's the end of today's class. Well, starting from tomorrow, we'll start our practical parts. We'll download Packet Tracer and understand simple basics and understand the basics of how to use Packet Tracer. So bye, see you in the next class.